Howdy, today on Flipping Science we're going to be looking at concentration. So concentration is very important in solution chemistry because it can tell you how much of a particular solution you need to react with another solution. So what do we mean by concentration? If you have a strong solution, you won't need as much of that solution to react with a weaker solution. And when I'm using strong and weak there, I'm really talking about concentrated and dilute. So if you are reacting a concentrated solution with another concentrated solution, you won't need as much of either solutions, whereas if you're reacting two dilute solutions together, you're going to need a lot more. So here's an example. We've got a domestic cleaning product. It says it is 3 times concentrated. That means that this small bottle has the same amount of active ingredient than this large bottle. So therefore you wouldn't need as much of the small bottle's cleaning product to do the same amount of cleaning as the larger bottle. So in chemistry, when we talk about concentration, we're talking about how much solute you have dissolved in a specific volume of solvent, and we measure it in moles per litre. So if you have a dilute solution, like we have down here, so a dilute solution won't have many moles of solute dissolved in a certain volume of solvent, whereas a concentrated solution will have a lot more moles of the same solute dissolved in the same volume of solvent. So that's where our unit comes from. It's the number of moles of solute dissolved in how many litres of solvent. The formula for calculating the concentration of a solution is C equals N on V. So the concentration of the solution is equal to the number of moles of solute divided by the volume of the solution. And you need to make sure you get it in the right units. So the number of moles of solute has to be in moles and the volume of solution has to be in litres to get the concentration as moles per litre, which is the typical unit used for concentration. Down here we have the magical triangle, so concentration is equal to the number of moles divided by the volume of solution, and then you can use the magical triangle to find any of the other two variables. So if you're looking for volume, it's the number divided by the concentration. If you're looking for the number of moles, it's the concentration times the volume. So here's a procedure for answering a question. You write down what you know initially and convert to the units that you need. You then write down the formula for calculating concentration and then you substitute and solve. So here's an example question. So it says, what's the concentration of 2 litres of solution that has 5 moles of sodium hydroxide dissolved in it? So write down what you know. So the way that I would do this is a sodium hydroxide solution we're making. So I'm going to use C and V, and then I'm going to put the concentration of what it is in brackets. So we know the volume of solution is 2 litres. So I'll write a little v, and then I write the sodium hydroxide because that's the solution that we're making, and its volume is 2 litres. So that's in the right unit, so I don't need to change anything. We also know the number of moles. So the number of moles of sodium hydroxide, so that's how I read that. So number of moles of sodium hydroxide is equal to 5 mole. The next step is to write down the reaction formula. So in this case, C equals N on V. We know our volume and we know our number, so we're looking for our concentration. The next step is to substitute in our numbers and solve. So we've got our concentration equals number of volume. Our number is 5 moles. Our volume is 2 litres, so 5 divided by 2, so 2.5, and our unit is moles per litre. Make sure you always write the unit. So here's another question. It says, how many moles of sulfuric acid are there in 500 mils of sulfuric acid solution of concentration 3 moles per litre? So we're going to follow our steps. So step 1, write down what you know. Step 2, write down the formula. Step 3, substitute and solve. So I'm going to write down what I know. So our volume of solution, so volume of sulfuric acid is 500 mils. Now I need to convert that into the units that we're using. 500 mils is 0.5 of a litre, so half a litre. Our concentration of sulfuric acid is 3 moles per litre. That's in the right unit. And that's enough information to be able to find the number of moles. Okay. So now I'm going to write down the equation. So if we look at our magical triangle, C equals N on V, N equals C times V. So my number of moles of sulfuric acid equals concentration times the volume. Concentration here is 3 moles per litre. Our volume is half a litre, so 3 times 0.5, so that's going to be 1.5, and our unit there is moles because it's number of moles of sulfuric acid. Our last question here, we are going to make it a little bit more interesting. We're told the mass of sodium chloride that's being dissolved in 1300 mils of water, and we need to find the concentration. So the first thing we need to do is figure out how many moles of sodium chloride are in 42 grams. So again, the first thing you do is you write down what you know. So my mass of sodium chloride is 42 grams, and then I need to find the number of moles of sodium chloride for that. So now I'm going to use the magical triangle from finding the number of moles and molar mass. That triangle, that's what we're going to be using for this one. So I know the mass of the sodium chloride. I can also figure out the molar mass given a periodic table. So that's what I'm going to find now. So molar mass of sodium chloride, I'm going to look at my periodic table and I'm going to see what the masses are. So sodium, if I look on my periodic table, its molar mass is 22.99. So I've got 22.99, and the molar mass of chlorine is 35.45. So 35.45. I'm going to add those two together using my calculator. So 22.99 plus 35.45. So molar mass there is 58.44. So molar mass is 58.44, and our unit there is grams per mole. Alright, from there I can figure out the number of moles of sodium chloride that I have. So if I look at my magical triangle, I've got number of moles equals mass over molar mass. So my number of moles of sodium chloride equals mass over molar mass. My mass is 42. My molar mass is 58.44. So go back to my calculator. So I do 42 divided by answer, and I get 0.72 to the number of figures we're going to. So we get 0.72 mole. Now that we have our number of moles of sodium chloride, we'll also write down our volume, because we've got 1300 mils here. So our volume of sodium chloride solution is 1300 milliliters, which is 1.3 liters. So we need to remember to turn it into the units that we need. Now that we have our number of moles of sodium chloride and our volume of sodium chloride solution, we can figure out the concentration. So I'm going to get rid of my magical triangle for molar mass now. Now we'll figure out the concentration. So concentration of the sodium chloride solution, C equals N on V, so the number of moles over the volume. Our number of moles is 0.72. Our volume is 1.3 liters. Now I'm going to use the number that's already in my calculator so that I don't have any errors with significant figures or with rounding. So I just divide that answer by 1.3, and I get 0.55 to two significant figures. So I get 0.55 moles per litre. So, Flipping Science today, we looked at calculating concentration, giving certain pieces of information. That's it for Flipping Science today. See ya.